Thanks for joining. Let's begin. So welcome to the horticulture webinar, Beyond the Datasheet, what you need to know before and ask before you develop your horticulture lighting solution. So I'm Marvin. I'm from Future Electronics. I will be moderating this webinar today. Thanks for Luminous, Eventronics, and Future Lighting Solutions to organize and support this event. So before we start, I want to show you something. So we will have a lucky draw today. So please stay online, and after the webinar, there will be a survey form. Please complete the survey. Then you will have a chance to win this very beautiful torch. It is using luminous flagship LED Luxon HL2X inside. So yeah, so please stay until the end and finish the survey form. Then we will have an offline lucky draw. So this is a live event. You may ask any question anytime in the question box. So you should see a question mark here in the from the toolbar. Then click on it, and then you can ask a question there. Our speaker and the supporting team will answer it as many as possible. Okay, so now let me introduce the speaker. Dr. Yang Liu has over 15 years of experience in LED industry. She joined Luminous in 2013 as the technical solution manager, assisting customers in product design and scaling success in final product manufacture. She is now Senior Technical Solution Manager, serving South China and West of Asia region. Ellen Gable is the Sales Manager for Southeast Asia and ANC for Eventronics. Ellen has been with Eventronics for over 7 years, but also has long experience in the power supply industry. Ellen is based in Singapore and supports markets around the region. And I'm Marvin Lee. I'm the Technical Marketing Manager at Future Lighting Solutions. I have been working in LED industry for more than 14 years. And now I'm leading the technical marketing team and the lab team to provide system solutions and support the customer for developing their luminaires. So we will start with Luminous presentation. Pass to you, Dr. Liu.
Okay. Good morning, everyone. Welcome to Horticulture webinar. My name is Yang Liu. Today I will share with you Luminous experience and insights in horticulture application. We observed the move from the traditional lighting, HPS, to LED in horticulture application in the last several years. That is because LED is more efficient, and LED compared with the HPS, LED has less waste material, and LED has a longer lifetime. And according to the study in Netherlands 2021, by switching from HPS to LED, the vegetable growers can save around 40% in lighting energy cost. So everybody know the advantage of LED lighting, but there still has some difficulties for the growers or the OEM to build a good LED fixture in this application. That is because LED is an integral part of the feature. It is not a single light source just by replace it in. It is a long-term investment, and the users the end user, the growers, are not familiar with the growing and the light from the LED. And also in the LED industry, the LED light efficacy, the spectrum options, and the photos delivered vary widely from one LED manufacturer to another one. So it has some difficulties for the OEM to choose the right LED and to integrate into a reliable system. So our purpose in this talk is to help you to reduce the complexity and to eliminate the objections with good decision making up front. So in following slides, we will talking about what is the OEM the property when they develop a lighting feature in the horticulture application. The first one is it should be the profitable solution, and this solution should be with a long-term reliability. There's no repair cost. Sometimes the maintenance cost is even higher than the feature itself, so we don't need a repair cost. And how to based on the current design solution socket to repeat to different customers. And we can tell you how to increase the likelihood of the success in this application. So we need to, for the OEMs, first they need to know their end customers' needs. For example, what kind of spectrum the end customer needs, and how to fulfill the requirements from the end customers, such as the PPF per wall, and maybe PPFD. And based on the requirement, to select the right LED parts, how to use different LED to form target spectrum the customer request. And based on the LED part, which to integrate into a system, which include the optical design, thermal design, and also the driver design, and move the prototype successfully to the mass production stage, and also guarantee a good quality with a long-term reliability. So we will share with you our insights in following slides. So first, let's look into the difference between the general illumination and horticulture applications. As you can see in the left figure in the slides, both the temperature and also the relative humidity in office in the general illumination scenario and the greenhouse are quite different. As you can see, the relative humidity in greenhouse is around 90, or even can go up to close to 100%. And the temperature in greenhouse is around 20 Hz higher than the office. So the application condition scenario, there's a huge difference. And also, if you look into the method when we evaluate the illumination intensity, so in general lighting, we usually use the lux, and in the horticulture, we use a different unit, which is a micromole per meter square per second. So that's because the evaluation system is based on a different response, the sensitivity curve. For the general lighting, it's based on the human eyes, and for the horticulture, it's based on the vegetables response curve. But if we normalize them, both these two units into the same unit, you can see that in office, we usually use 400 lux. But in greenhouse, it is around 250 times higher. So the both the requirement and the application conditions are huge difference. So can we just simply apply the LEDs used in the office into greenhouse? The answer is yes, but we need to add more conditions, such as the we need to perform more reliability testing. So I will share with you our insights in following slides. So when your supplier presents LED datasheet behind you, in front of you, you need to not just read the normal informations. You need to look into the detail, since the detail can tell you the real story. For example, in our datasheet, in our last round sample series, we not only code the performance at a low temperature, say TJ of 25 degrees C, we also have the performance at a higher temperature at a TJ of 85 degrees C. Since the performance at TJ 85 degrees C is more close to the real application in the greenhouse, and it can show the real performance and long-term reliability in the application scenario. And one more point is the VF range. As you can see here, for example, our SunPlus 3030, the VF range is only the range is only 0.1 V. That means we can realize a even current distribution through the whole lighting fixture. In horticulture fixture, usually there are thousands LED package inside, so there are different strains in parallel. So if you have a big variation of the VF, the current in each strain is not even. It will cause the not even light distribution over the fixture. It has impact on the plant growth, and also the even current distribution in different strain will contribute to a longer reliability in the whole system. The narrower the VF, the better. And we also recommend you to look into the maximum rating in the data sheet. For example, the maximum driving current and the maximum TJ. One more point we would like to highlight is in our LED, we allot 3 reflow cycles. So this spec and also show the robustness of the LED. In many countries, the greenhouse has different name. For example, in German and also in Chinese, a greenhouse is also called as warm house or a humid house. So it reflects the application conditions in horticulture is quite different from the general information. So as you may know, the high temperature and the humid environment is tough for the electrical parts. So how to maintain the long-term reliability in this special application scenario? We recommend to perform a full series reliability testing. So as you can see here, we perform a very important reliability, full series reliability on our SunPlus series, as shown here. For example, we perform the WHTOL testing. I would like to highlight here is the testing condition. Please look into detail of the testing condition. For example, in our case, we perform at 85 degrees C and 85% relative humidity. So other suppliers may perform at a lower temperature, say 65 degrees C or lower relative humidity. The higher the temperature, the higher the relative humidity can give a more tough testing condition on the LED package. And also, we perform the testing with the on-off testing. It's a 3 minutes on and 3 minutes off. This testing method, on-off testing, provide a more stress on the LED package, since the moisture can go up and go out of and inside the LED package. The stress is it has more stress on the LED package compared with the straight on or straight off testing. The testing duration is 1,000 hours, and we perform the high temperature operation live testing at the maximum driving current of this LED package. Here is the we took the Sulfide 3030 as an example. Of 480 mA is the maximum DC driving current of the package. And also the cycle, we performed 1,000 cycles during the reliability testing. The last one, but it's the most important one, is the hydrogen sulfide testing. We following the DATASheet standard. I would like to highlight here is the testing temperature. We select 40 degrees C. We have performed the benchmark testing with our LEDs and our competitor LEDs. Some competitors can pass the hydrogen sulfide testing at a lower temperature, say 25 degrees C. But when we increase the temperature to 40 degrees C, some of the competitor LEDs will fail. So don't just look the general information. Please look in detail of the testing conditions. So it will tell you whether the LED is really robust enough for the long term. So besides the reliability, we also have the lifetime, same as the general lighting. For the horticulture application, we also have the MAT report. In horticulture application, we call it as a Q data. It's a Q70, Q80, and Q90. It's a quantum flux maintenance data. For our Sulfide series, including white and color LEDs, we can fulfill the DLC premium Q90 larger than 36K hours requirement. Besides the lifetime, we also care for the color changing. Since color change is easily observed and it can indicate the things whether the LED quality is good enough over the time. And also in horticulture application, the color change may cause the spectrum, the slightly change in the spectrum, and it can have impact on the plant growth. So in luminance, we care for subtle difference, including the flux maintenance and also the color maintenance. So finally, I will share with you luminance Sulfide series portfolio. We have a full series LEDs covering the white LED, from the white LED to the color one, the deep red far red, royal blue, and we also have the special color such as lime and purple series. And the power range is from the middle power, such as the Sunplus 3030 and 2835, to high power range, such as Sunplus 5050, Sunplus HPE, and Sunplus 20. Currently, the most popular solution is use the white LED plus the deep red to form a continuous spectrum. Since LED is very flexible to select the wavelengths, so we can provide the professional support for the customer to generate the target spectrum, the request by the end customers, and provide a full series professional support to our customers. So to summarize my presentation today, to build up a business in horticulture application, we need to consider the product dependability, and beyond that, we also need to consider the product availability, which include whether it has a stable supply chain, and to consider the ecosystem, including the optical, thermal, and driver design. And the next speaker in today's webinar will share with you their insights in the driver design. And we believe with our strong and professional technical support, and you can scale your business in horticulture application. Thank you very much for your listening, and I will go back to Marvin.
Thank you, Dr. Liu. Okay, so next we will have Alan and Martin to present for Eventronics.
Okay, so good morning, everyone. This is Martin, a field application manager from Eventronics. Today, I'm very happy to join with you through this online channel, and I will introduce something beyond the datasheet. So I will not do the specific product introduction here. If needed, we can have another seminar to introduce more about our products. The introduction will let you more understand about the driver design and application before you develop the horticulture lighting solutions. Let's go to the first slide. We will go through this presentation through these three parts. The first one is datasheet health. As we all know, there are a lot of parameters in datasheet. So the introduction will let you more understanding about the critical parameters when you design your horticultural lighting system. And the second part is the horticulture pitfalls to avoid. To more about the design, more about the applications, then can reduce your design working time and reduce the reworking time. The third part is very important for our customer. The quality extends beyond the product performance. So it's very important for our customer to select a reliable and long-term cooperation vendor. Let's go to the overview for the horticulture applications. So here it shows the different applications for the horticulture lighting market. It will include the different power from low power and high power, and also you can see have the different mechanical design. So Eventronics works with the world top class horticultural lighting company and understand where about these applications. We can provide the multiple solutions for these applications. So if you have any applications about this market, you can feel free to contact with us. Let's go to the first part, the data health. Let us talk about the operating region. So here is a typical IV operating curve of our programmer driver. From this curve and the table below, you will see the maximum output current of this driver is 5.6 ampere, and the maximum output voltage is 163 volts. If you directly multiply these two parameters, then you will get a power more than 900 watts. But definitely this is not correct, because the maximum power of this driver is 680. So the driver cannot output the maximum output current and the maximum output operating voltage at the same time. So when you design your fixtures, you should understand how to get the maximum output operating voltage. So you can get it from this formula. You can use the maximum power of this driver divide the program output current. Then you can get the maximum operating voltage of this driver. For example, when you program the output current to 4.2 ampere, then you can get the maximum output operating voltage is 163 volts. When you program the output current to 5.6 ampere, then you can get around 121 volts. So this is very important for design your LED fixtures. Meanwhile, another thing we should put on attention is the maximum forward voltage of your LED loads. We should consider the impact from the temperature and the tolerance, and make sure the load voltage is below the maximum output operating voltage of the driver at the programmed current. So next we talk about the efficiency. The efficiency is very important. Everybody knows it can reduce the power loss and also can improve the PPE, PPF of the fixture for the horticulture lighting application. Correspondingly, it can improve the revenue and the yield of your project. So in our datasheet, there is a typical efficiency, but it only represents the single operating point. So when you design your fixtures, you should look at the efficiency as well. So meanwhile, so here it's like we take an example for efficiency curves, which from our two models. And if you do the comparison at the 90% efficiency, you will get the result. The driver have the relative higher efficiency at 6.3 ampere. So it means that the efficiency is not always high at the lower output current. So when you design your fixtures, you should look at this kind of efficiency curve, then select a suitable operating point for your fixture design. Then get the expected PPE, PPF for your applications. So here is the model definition. Here is an example. The fixtures has the 3.8 ampere and 171 volts. This is actually 650 watts driver. So then try to select a suitable driver models. The left side is a 3.5 ampere driver. The maximum current of this driver is 3.5 ampere. So it cannot reach your 3.8 ampere target. And also here is another model, the 5.6 ampere model, but the maximum output voltage of this driver is 163 volts. So it still cannot meet your target. So there is some gap between the different models. The output current and voltage are not always same. So when you design the LED configurations, you should avoid this gap. So you can check the driver datasheet first, then design your LED configuration. So next about the temperature. The temperatures is very important. As we say, there are two typical temperature in our datasheet: the case temperature for safety and the case temperature for warranty. Case temperature for safety, actually, this temperature is designed to follow the standard. Normally, it's not exceed the 90 degrees C. So the safety lab will test the driver to ensure the safety and the basic performance at the short time. It's not represent the long-term reliability working. So for your design, to ensure the reliable working, you should ensure the driver to work at the warranty case temperature for this driver is 80 degrees C. Then you can get the reliability. For the warranty case temperature, is get from the multiple data, which like includes the lifetime, the reliability data, the MTBF, the field application data. So the lifetime is calculated by the ECAP. So in DLC, it requests the 50,000 hours as specified ambient temperatures. So you can find the correlation in our data sheet. But the lifetime is one factor to impact the reliability. We just mentioned that for the drivers, it's not only includes the ECAP, it also have the MOSFET and the transformer. So you should ensure the reliability for the all components. And also for the working ambient temperatures is really depends on the fixtures design. The fixture CMR design will directly impact the working ambient temperature for the driver. So here is the like code for the reliability. The reliability is data, so combined with the multiple data. So the second part is the horticulture pitfalls to avoid. This is also very important. The first one is the Rcd design. Here is a typical fixtures and driver for horticultural lighting applications. As the way I say, this is very common installation type. The driver and the fixtures installed independent. So some, and also the driver and the fixtures installed at the seal of the greenhouse. So consider from the safety perspective, normally it's requested to ground the fixtures, but the fixtures installed at the top side of the greenhouse is not easy and convenient to add the additional grounding screen to ground the whole system. So our driver have the special design to operate RS interface at output, so you can connect the driver and the fixtures together to ground the whole system. It's really help to simplify the field wiring. The second part is the connector. As I just mentioned that the fixtures installed at the top side of the greenhouse, so it will request the quick and safe connection. Then the connector will be used for the application. When you select the connector, you should take care of the certificate, the ingress protection, the rated current and voltage. For the certificate, you should ensure the connector have the corresponding certificate at your application market. And also, if the driver target to install at the WAN location or IP67, you should ensure the connector to meet it as well. And meanwhile, for the electrical parameters, it should be evaluated together with the driver. Here is an example for the fixtures at 4.2 ampere and 200 volts load. Then you select our ESM 880S for 20 models. If you look at the data sheet, the maximum no load voltage of this driver is 350. So in this case, you will need to select a 600 volts connector. Sometimes if you have the existing 300 volts connector, then you should consider how to modify the LED configuration to get the higher driving current. Then can have the lower forward voltage to select the lower rated connector. The next about the inrush current. As we all know, for the greenhouse, there are a lot of fixtures installed at the same room. When you start the whole system, the inrush current can be accumulated, and the nuisance triggers the protect device. The protected device actually to protect the whole system as abnormal conditions. It's not expected to protect at the normal start of the whole system. So our high power driver design with very low inrush current. So here is a table to show the inrush data. As you see, at the different testing voltage is where have the lower than 20 ampere inrush current. The lower inrush current will help to improve the working stability and reliability for your whole system. And also it can increase the carrying number of the drivers for the MCB circuit breaker as well. So next is about the afterglow phenomenon. So sometimes you will see the fixtures still keep a very light brightness at the field when the fixture at off state. We call it as the afterglow phenomenon. So for our drivers, we design with very low output leakage, voltage, and current. And but the LED board has a parasitic capacitor, and also some LEDs has very sensitive on the current. So even the small currents can light up the LEDs. So this phenomenon is caused by the system level. Before you deploy the fixtures to the field, we suggest that you do some tests at your lab to simulate this phenomenon. The first one is like disconnect only one input signal, like a neutral wire, and the second method is short the dimming plus and dimming minus wire to see whether this phenomenon happened. If it happened, then you should do some troubleshooting to optimize the whole system to avoid. Here is a table. Here is a table to show the lighting schedule for the Canopy cultivation. So as you see that sometimes the fixtures will be at the off state. So it's very important for these parameters. So now even we don't see the specific impact for this afterglow phenomenon to the horticultural lighting application, but normally we suggest to you take time to validate it and avoid this phenomenon. The third part is also very important. This is the quality extends beyond the product performance. For Inventrons, our goal is to work with our customer to have win-win business and help our customer to grow the revenue as the long-time operations. And also the customer is not only put attention on the units cost, and you should to take care of the cost during the whole life of the fixtures. So when you select reliable and non-operation suppliers, you should consider from the warranty, sourcing, marketing, R&D, and safety and operation. And also you ask the question, do you have the local support? Do you house your manufacturing process to ensure the reliability of driver? Do you have the global warranty team to support us? So how's your supply chain and management? So all of these questions and consideration will help you to find a reliable cooperator and vendor to support your long-term cooperation. So here is a summary for this presentation. The first one, when you design your horticultural lighting solutions, you can get the help from us. If you have any questions about the driver, about the application, so then can avoid the pitfalls when you design the whole system to reduce the reworking time for your design. The third one is very important to select a good and reliable partner which invests the quality in the product and the service. So here is email for me. So if you have any questions, you can feel free to contact with us. So here is the presentation and today. So we can go back to Marvin.
Thank you, Martin. Okay, so this is the last presentation. So I will talk about system design best practice. So what are the recommended steps for defining a horticulture system solution? So we want to show you a systematic method to design a horticulture luminaire. So you know, it is you may be very experienced in general lighting, but in horticulture it is a bit different, and there are many different LEDs in the market. We want to have show you some systematic way to do the design so that it can shorten your design cycle. So just 3 steps. First, define the light source, and then select the LEDs. After that, define the system. So define the light source. We need to understand the spectral preference, the target spectrum, and also the target flux as well. Maybe we only know the target flux density. If so, we need to know the distance and also the cell size, and then we can calculate the target flux. After we understand the target, we can select the LEDs. It is very hard to do because just many LED options in the market. So we need to choose, and we need to compare different LED and choose the most suitable one to use. And then before we do a simulation, we need to understand the system losses, like the optical loss, the thermal loss, and also the driver loss as well. After that, we can determine the LED drive current. The LED drive current need to meet the LED need to meet the target efficacy as well. After that, we know the single LED flux output. We can calculate the total LED count. It's an initial estimation. And then we can go to next step, define the system. We need to define the board dimensions, the board count, the interconnection as well. And then we can select a suitable LED driver. We also need to understand the output range of the LED driver, which will affect the board design, affect the LED array design as well. After that, we may need to choose another driver. And then in the end, we need to do the all simulation again. We need to ensure our proposal, our solution, which can meet all the spectrum targets and also the target first targets as well. Of course, we need to make sure it is within the LED driver output range. So, okay, so let's go into the details. The first step, define the light source. So we need to understand the spectral preferences. It is usually provided by the end customer. The end customer usually have a target spectrum in their mind. We need to ask, so because it will affect what approach we take. So we have single channel white plus deep red LEDs approach. It is now dominating the market. It is just very low cost, high efficacy, and very simple because just single channel using the mid power 3030 white LED with some high power deep red LEDs. So it is very simple, but with many other very good features. Like it consists of green spectrum. You see the green spectrum here. So it is very important to most of the crops. It makes the for example, it makes the vegetable more fresh. But there are some trade-off, still some trade-off, like the spectrum flexibility. We cannot adjust the spectrum after at the site because it is just single channel. And also we use mid-power LED, so the light engine will be bigger size. There are other approach like two-channel variable plus deep red LED approach. So for example, if the customer they want to adjust their spectrum for the crops at different stage, then maybe they want to adjust the current on for the variable and also adjust the current for the deep red at different stage. And also they can add a fiber LED inside. So it is more compact, higher cost, yeah, but higher flexibility. The last one is multi-color tunable. If the customer they wants to do some research to find out their optimized light recipe, then maybe they need this approach. So it is a multi-channel control and also using multi-color LEDs, so they can achieve different spectrum anytime, but it is very high cost. Okay, we also need to understand target first. So target first usually is very depending on application. A greenhouse or vertical farming, they need different target first. And also depending on the target crops, canopies or leafy greens, they need different target first as well. We also need to understand whether the LEDs serve as supplemental lighting. So there are usually two scenarios when you ask the customer for the target first. Simple scenario, the customer provides PPF, the first value target. So if so, we can very simple. We can just divide this target first by the single LED flux output. Then we will be able to calculate or estimate the LED count. The complex scenario, the customer can only provide us PPFD, a flux density value. If so, we need to understand the distance from the canopy and also the cell size, so that we can do system simulation to calculate the target flux value back with using our simulation tool. After we understand the target and and also the requirements, then we can go to next step, select the LEDs. So the first step is in this stage, evaluating LED options. There are many different LED vendors in the market and also many different models. So it is hard to do just because too many, and also the LEDs keep upgrade and improve, or maybe every quarter. So your information may not be up to date, but no worry, we have some tool here to help you. We have our app, our mobile app, LSS, to help you to provide a quick overview of LED options, so that you can select few of the most popular and the most competitive LED. And then you can go to the next stage is you can compare different LEDs in details, and then you can, based on the performance, based on the let's say the efficacy of the LED, based on the value, PPF per dollar at broad level, and also based on the availability. The lead times is very critical in this COVID-19 situation. So you may base on these three criteria to choose the most suitable LED. And we have another tool, usable light tool, which can help you to compare different LEDs, compare their performance at different conditions. So we have already 25,000 different LED models in the tool, and we keep the tool most updated. Okay, so before we do the system simulation, we have to estimate the system loss. We have to be very conservative in this estimation, because there are always some unpredicted potential losses on the luminaire. So let's say the optical losses, it could be from the conformal coating, it could be from the secondary optics. If you want to apply, if you want to have a special beam pattern, then you may need to use secondary optics, and it will generate some losses as well. And if you want to have a glass cover or some other kind of cover on the PCB board or on the luminaire, then there will be some losses as well. The driver losses, when you estimate the driver efficiency, you will be very easy to find this value from the driver datasheet, but we recommend you assume 2% lower than the datasheet value, because the efficiency can be affected by the loading and also input voltage as well. Usually the driver is the higher the power, the lower the driver losses. Yeah, and then the last one is the thermal losses. When the LED TJ, the junction temperature of the LED is higher, the LED performance will be lower flux. So we can leverage the ULT, the online tool, to simulate the LED performance at different junction temperature and also different drive current as well. We recommend you assume the TJ at 60 to 80 degrees C, and based on our experience, usually the white LED and the deep red LEDs are similar TJ, due to the deep red is lower thermal resistant, and also the deep red is lower VF as well. Okay, then we need to determine the LED drive current, and also we need to make sure the LED performance is able to meet target efficacy. So yeah, assume we use the single channel white LED and deep red LED design. We recommend you to take 100 milliamps at starting point for 3030 white LED, and also okay. And you may ask a question: which CRI we should use in this calculation? In general lighting, usually 70 CRI is higher efficacy, but in horticulture, it is not the same. We use micromole per joule, and it is spectrum dependent. And usually the 80 CLI LED is higher efficacy than the 70 CLI LED. So we recommend you to start with 80 CLI first. And go back to the drive current. For example, we use a 100 milliamps as a starting point. Of course, you can overdrive, increase the drive current to get higher flux, or reduce the current to get higher efficacy. Assume you use 100 milliamps. The deep red will be 4 times to 6 times of the current of white LED. That means it will be 400 to 600 milliamps. Okay. And then we can use the ULT to estimate the drive current, and we need to make sure the drive current is meeting our lifetime target. Okay, then we use the ULT result and enter the data to our Excel tool. The Excel tool will help you to generate the spectrum. You may verify whether this spectrum is meeting the target spectrum, and also this tool will help to calculate the PPFD, and also it show you the DLI result here. If everything okay, then we go to the next step, define the system. So we need to define the board dimension, board count, and also the interconnection. So the board dimension is very depending on the mechanical design. There are multi-bar design or single heatsink design. For multi-bar design, the board will be around 30 to 50 millimeters width. Yeah, and the board usually has two options of 2 foot and 4 foot boards length. The 4 foot board is better for series connection and less connectors, so lower cost. The 2 foot boards are easier for shipping because it is shorter and also better for parallel connections. So with this information, we can initially calculate the board count on the luminaire, and then we need to consider how we connect the board. If we connect the board in series, yeah, it is good for high power LED, but the voltage will be very high. We need to take a look whether the driver can cover such a high voltage. If we connect the board in parallel, we need to make sure the VF is matching to avoid the current hawking issue. Yeah. So we actually how the board connected is also very depending on the driver selection. So let's go to the driver selection. We have a driver selector tool to help you to select the driver. So the first we may do an initial search first. So we just need to enter the input voltage and the output power to choose to have an initial selection for the LED driver, and then we may need to adjust the LED array again, because, for example, if your initial proposal was 11 white LED paired with 1 different LED, then it doesn't well for divide. It's not easy to do the PCB layout. Then you may want to add 1 more LED to make it 12 paired with 1 different LED. If so, because we add 1 more white LED, the spectrum will be different. You may need to change the layout to become like this, 6P times 2S. And we use 600 milliamps input, so you can see the difference. Initially was 400 and now 600. The white LED drive current is still the same, but the deep red LED will be 600. Yeah. Once you fix the design, you may connect different cluster together. You can connect them in series, and but the voltage may be too high if you connect all the cluster in series. And then so you may need to connect them in series like this. Okay. Once you change it, you need to do the driver selection again. Okay. So once actually just 3 steps. Define the light source, select the LEDs, define the system. So again, you need to rerun all simulations again to make sure your proposal which can meet all the targets and within the driver output range. After that, you can consider to add some feature like Bluetooth mesh control on your luminaire. Again, we have different tools available here to help you to accelerate your design. You can contact our sales or TSM or send an email to this email address. We will help you. Yeah. Okay. So yeah. So let's see. We are overrun a bit. So we can maybe we can have a 5 minutes Q&A. Then yeah. So maybe we can choose a question to answer. Dr. Liu, do you want to answer any question? Yeah, you can choose one question to answer.
I already.
Hello. Yeah.
Hello. Thank you, Marvin.
Yeah.
I already answered my 2 questions in the chat room.
Yeah. Yeah. Okay. Okay. Yeah. So okay, seems
So
that's all question. All the question has been answered by our presenter. So yeah. So yeah. Thanks for joining, and also thanks for the speaker to support and organize this event in such a short period. And again, for the audience, please stay and complete the survey. You will have a chance to win this torch. Yeah, this torch. We have 10 torch available. So please stay and complete the survey form. So again, thanks for joining. We are looking forward to bring you more webinar in the future. Take care. Bye-bye.